So welcome. In this lecture I will discuss about AM receiver. In AM receiver, in the fifth module, you have to study this AM receiver and FM receiver, tuned radio frequency receiver and super heterodyne receiver. So AM receiver mainly two category: tuned radio frequency receiver and super heterodyne receiver. So first I need to discuss about tuned radio frequency receiver. This is the general block diagram of a tuned radio frequency receiver. So the signal is picked up by this antenna. So definitely the incoming signal will be radio frequency only, and that signal is picked up by this antenna. So the signal is received by this antenna and it is given to an RF amplifier. Why? Because the incoming signal is the signal which is coming from the free space. We transmit the signal and signal is transmitted over a free space, so definitely the signal strength will be get reduced. So that low signal, feeble signal is received by this antenna should be amplified. So the first stage is always RF amplifier. So the incoming RF signal with a low energy is amplified with the help of an RF amplifier. So the signal is sufficiently boosted to a particular voltage level, and then it is given to the demodulator. So why this demodulator means, in the transmitted section we use modulator before transmitting the signal. Why? Because the incoming signal is low audio frequency, low signal only, so it should be up converted to a high frequency, then only we can transmit to free space. So there we use modulator, here we need to use demodulator. So just the reverse operation what we done in a transmitter. So what here it is, the incoming RF is demodulated or down converted to audio frequency with the help of this demodulator, and this signal is now the output of this demodulator is nothing but AF, and that AF is amplified by this AF amplifier. So this is nothing but audio frequency amplifier. So this signal, demodulated signal, it shouldn't have a sufficient voltage level. So we need to use an AF amplifier to amplify the received AF frequency signal. Then the signal should be connected to a loudspeaker. Before that we need to give a power amplifier. Why? Because the signal shouldn't have enough energy or enough power. So we need to amplify the signal with the help of a power amplifier. Thus this amplifier boosts the power level of the AF signal to a sufficient voltage, so a sufficient power, then it is given to the loudspeaker. So here you will get your audio what you intended to transmit it at the transmitter. So this is a general block diagram of tuned radio frequency receiver. So the thing is, you have to come across 2 points here. If the resonant frequency here, actually this signal is picked up by this RF antenna, this antenna, and it is given to the RF amplifier. So the amplifier here used is a tuned amplifier. So the tuned amplifier has a resonant frequency FR is equal to 1 by 2 pi root LC, and this frequency is determined by this L and C components, and the quality factor of this tuned circuit is resonant frequency by bandwidth. Okay, that you know. In AM broadcasting, the broadcasting frequency range is from 550 kHz to 1650 kHz. So this is about the tuned radio frequency receiver. So here the signal, the amplifier used, it is a tuned amplifier with a resonant frequency 1 by 2 pi root LC. So some characteristics parameters of receivers are sensitivity, selectivity, fidelity. So what is sensitivity? It is the minimum signal strength that should be maintained at input of a receiver to get a standard output. That means you have a receiver, there you should keep a minimum signal strength. Okay, with that signal strength the receiver should be able to obtain a standard output. So that is what is called sensitivity. Sensitivity depends upon overall gain of the receiver. That means overall gain of the receiver is high, then we can say that the receiver is more sensitive. That means very small signal you give, it will give a standard output. For example, you give 10 volt at input, you will get a standard, for example, 50 volt output in a system. The same system, you give a 0.1 volt, still it is able to obtain a 5 volt, means which one is more sensitive? Second one. Why? Because as much as low signal you give to the input, the system should be able to respond to that particular input and should give a constant output. That is what is called sensitivity. So that sensitivity depends upon the overall gain of the receiver. So the number of amplifier stages, as the number of amplifier stages increases, then the gain increases definitely as the number of amplifier stages. If you increase more number of amplifiers, or if you put more number of amplifier stages in the system, definitely the gain of the system increases. So definitely you can increase the sensitivity. So next characteristics is selectivity. It is the ability of receiver to select the required frequency only. That means you are design a system to select a particular frequency, say 100 kilohertz. You need to select only 100 kilohertz, and under that condition, your system should select only 100 kilohertz. Above and below this 100, for example, say if the system selects 105 kilohertz, then the intended operation gets violated. No, the incoming signal is, your system is designed to receive only 100 kilohertz. So the system should select only that 100 kilohertz frequency. All other frequencies should be blocked. So that is the selectivity. It is the ability of the receiver to select the required frequency only. So normally the bandwidth of AM, we normally kept it as 10 kilohertz. Consider an example. I am taking a receiver with a tuned frequency of 800 kilohertz. Okay, so the incoming center frequency I am fixing it as 800 kilohertz. So what is the frequency range? 795 kilohertz to 805 kilohertz. That means you know that the center frequency is like this. This is the center frequency. Then there is a frequency variation. So lower and upper. So center is 800 kilohertz and bandwidth I am keeping it as 10 kilohertz. That means from 800, 5 upper side, 5 kilohertz lower side. So total bandwidth become 10 kilohertz, no problem. So the center frequency I am taking it as 800 kilohertz. So the lower frequency is 795, upper frequency is 805. So that the difference between these two become 10 kilohertz. Now the thing is, bandwidth is 10 kilohertz. Okay, I am fixing the resonant frequency as 800 kilohertz. So what is the quality factor? Quality factor is nothing but resonant frequency by bandwidth. Okay, so quality factor is nothing but resonant frequency by bandwidth. So Q is equal to 800 by 10, that is 80. Okay, so the quality factor is 80 here. This is about the quality factor. So the thing is, suppose you change the resonant frequency. Suppose you are changing the tuned resonant frequency. This frequency is changing. Okay, then this frequency is changing. Definitely this also changing. Okay, yeah. So always we need to keep bandwidth equal to 10 kilohertz. Okay. So resonant frequency is nothing but Q by bandwidth. From this equation C, from this equation you can resonant quality factor Q equal to resonant frequency by bandwidth. So take bandwidth. So bandwidth equal to resonant frequency by Q. Okay. So this is the tuned circuit. Here is the resonant frequency comes here. So by adjusting L and C, you can adjust the resonant frequency. Okay. So by adjusting resonant frequency, definitely bandwidth equal to resonant frequency by Q. Okay. So once your quality factor is fixed, it can't be changed. Okay. So here actually you are changing the resonant frequency. So bandwidth quality factor keeping constant, then bandwidth is getting increased. Okay. So resonant as you bandwidth equal to resonant frequency by quality factor. As you increase the resonant frequency, definitely bandwidth will be increased as we kept Q constant. So this creates a problem. So we are keeping 10 kilohertz as a bandwidth for this AM. So as the resonant frequency increases, by keeping Q constant, then bandwidth increases. So what happens is 10 kilohertz exceeds, the bandwidth is exceeding. For example, if I fixed it as 10 kilohertz, but when I increase the resonant frequency, the bandwidth is also increased. So new bandwidth will be greater than 10 kilohertz, might be. Okay, so under that condition, what will happen is unwanted frequencies are accepted, or unwanted frequencies are also received by this system. So adjacent frequencies are coming into the system, though. So this adjacent frequency may be some other station frequency that also received, and our signals get interfered with this frequency, so we'll get a noise at the output. We won't get an exact high quality audio at output. Why? Because the bandwidth is getting increased, so adjacent and unwanted frequencies are accepted by this system. So this is the problem with the tuned frequency receiver. To overcome this, we introduce super heterodyne receiver that we will discuss in next lecture.